Hi guys, this is Gopika here, and today I'll be discussing the main topic of this chapter. Okay, so actually tests of similarity is very much similar to the test that you learned in congruency of triangles. Okay, and actually they are almost we can say they match most of them, but the main difference is when you say two triangles are congruent, there the sides are also of equal length and the corresponding angles are also congruent. Sides are also congruent and angles are also congruent. But when we are telling that two triangles are similar, what we mean is their shape is same, their size is not same. Okay, may not be same, it can be same or may not be same, but essentially their shape should be same. So for the shape to be same, there are two properties that are important. One is they're congruent, their corresponding angle should be congruent, and the second is their corresponding sides are in same proportion. Okay, so there are two things when we are talking about similarity. That means two figures are in same shape or they are similar when the corresponding angles are congruent and the corresponding sides are in same proportion. They need not be congruent, they should be in same proportion. Okay, for similarity of two triangles, the necessary conditions are that their corresponding sides are in same proportion and their corresponding angles are congruent. Okay, now just like tests of congruency, here also we don't need to check all the 6 conditions. Means all 3 angles and all 3 sides we don't need to check. If any 3 of them gets satisfied, then we can say that automatically all the conditions will be satisfied. Okay, just like in tests of congruency how we did, we pick any 3, 2 sides or 1 angle or 3 sides. Similarly here also, if any 3 of them is satisfied, then the rest 3 will be automatically fulfilled. So out of these conditions, when 3 specific conditions are fulfilled, the remaining conditions are automatically fulfilled. Now what are those 3 specific conditions, or what are the combination of that we will see in the test of similarity. This means for similarity of two triangles, only 3 specific conditions are sufficient. Similarity of two triangles can be performed or be confirmed by testing 3 conditions. Okay, let me choose the by testing 3 conditions. The groups of such sufficient conditions are called tests of similarity, which we shall use. Okay, so those combinations of 3 specific conditions we will call tests of similarity. It may be 3 sides, 3 angles, 2 sides and 1 angle. However, all those combinations we can call as tests of similarity. Okay, and that we will use to prove if 2 figures are similar or not. Alright, so let's see the first test of similarity. Okay, so without a doubt the very first test is obviously of all 3 angles. See, the main condition in 2 figures to be similar is that their corresponding angles are congruent. So first thing that we should be checking, or the first form of test or combination should be AAA test. That means all angles, 3 angles we are testing. For a given correspondence of vertices, when corresponding angles of 2 triangles are congruent, then 2 triangles are similar. Okay, now if you see triangle ABC and PQR, here A is corresponding angle of P, B is corresponding angle of Q, and C is corresponding angle of R. Okay, you know how to decide corresponding angles, right? A is corresponding to P, B is corresponding to Q, and C is corresponding to R. Now we need to check each corresponding angles are equal or not. That is, if angle A is congruent to angle P, angle B is congruent to angle Q, and angle C is congruent to angle R, if you see in the figure, then we can say that these 2 triangles are similar. Their sides may be equal, their corresponding sides may be equal, or they are in same proportion. Either of them can happen. Okay, if the sides are equal, then those triangles are congruent. If they are in same proportion, then they are similar. Now however, every congruent set of triangles are similar, but every similar triangles are not congruent. Okay, so this is the first basic test. Now they have given more information about this test of how it works, or a proof of how this will work. If only 3 angles we are checking, we are not checking about any side, right? So if just 3 angles are congruent or corresponding angles are congruent, then how can we be sure about that the sides are in same proportion? So for that we will see the proof of this test. Okay, Okay, so this is proof of AAA test. So there we have two triangles, triangle ABC and triangle PQR, where A is congruent to P, B is congruent to Q, C is congruent to R. Okay, three angles are congruent. Now aim is to prove that triangle ABC is similar to triangle PQR. Okay, let us assume that ABC is bigger. So now let's assume that one of these triangles is bigger in size and their shapes are same. That is what we have to prove. So let's assume one of them is bigger. So ABC is bigger. Now we will do a construction. We will construct Mn in such a way that PQ and PR is equal to AM and AN. That is PQ is equal to AM and PR is equal to AN. So actually we are drawing a smaller triangle within ABC such that PQR match AMN. Okay, now they will match, that also we will have to prove. Okay, now mark point M on AB and point N on AC such that AM is equal to PQ and AN is equal to PR, and then join MN. Okay, after marking the point. Now show that triangle AMN is congruent to triangle PQR. Now for showing the congruency we will have to use the tests of congruency that you learned previous year. Okay, after showing they are congruent, then we have to show that MN is parallel to BC. To show MN is parallel to BC, we will be using the corresponding angles test. So this part is that you have to work out this part. Okay, now let's see how it comes. Okay, if you want you can pause the video and try to work it out yourself, and if you're not getting, then refer or continue watching the video. Okay, so this is how we will prove it. Now in triangle AMN and triangle PQR, there are two things that we should notice. AM is equal to PQ. Okay, why AM is equal to PQ? Because that is by construction, because we have marked M such that AM is equal to PQ and we have marked N such that AN is equal to PR. So by given or by construction we can say side AM is congruent to side PQ and side AN is congruent to side PR. One more thing we know, angle MAN is congruent to angle QPR. Why? That is given. A is equal to P. So A I can write it as MAN angle and P I can write it as angle QPR. So they also are congruent. That is from the given information. So by SAS test of congruency we can tell triangle AMN is congruent to triangle PQR. So that half part of the proof is done. Next we need to show that MN is parallel to BC. Now using this congruency we can come to the conclusion that angle AMN is equal to angle PQR because they are corresponding angles of congruent triangles. Okay, that means this angle M and this angle Q are corresponding angles of congruent triangles, so they are equal. And also from the given condition B is equal to Q. Now M is equal to Q and B is equal to Q. That means angle M is same as angle B. So same thing we have written here. Angle AMN is equal to angle PQR by CACT. Angle PQR is equal to angle ABC. This is from the given conditions. Therefore, from 1 and 2 we can say triangle AMN is equal to, angle AMN is equal to angle ABC. Okay, now these are corresponding angles. So by corresponding angles test, we can say MN is parallel to BC. Okay, MN is parallel to BC. Done. So once we prove that they are parallel, we have a triangle where MN is parallel to the third side. Then we can easily apply the basic proportionality theorem that we learned in just this chapter. Okay, in the beginning. So by basic proportionality theorem, MB upon AM is equal to AM upon MB is equal to AN upon NC. Now we apply invertendo, we can write MB upon AM is equal to NC upon AN. Okay, inverse on both the sides. If two ratios are equal, their inverses also match. That is what we mean by applying invertendo. Okay, now MB plus AM upon AM. Now we have applying component over here. That is we are adding denominators to the numerator on both the sides. Applying component. Now what is MB plus AM? MB plus AM is AB. So AB upon AM is equal to, similarly NC plus AN is AC. AC upon AN. Okay. Therefore AB upon PQ is equal to AC upon PR. Now similarly it can be shown that AB upon PQ is equal to BC upon QR. So one ratio we already proved and the one half of the ratios we already proved. Similarly we can prove the other half also, and hence we can prove that all these corresponding sides are in same proportion. Okay, simple. Now I hope you understood this step. Here AM and AN is replaced by PQ and PR, okay, because that is what they are of equal measures or equal length, so we can replace the value of AM by PQ and AN by PR, okay, and hence we arrived here. And similarly we can prove AB upon PQ is same as BC upon QR, okay. Therefore all these three are in same proportion. If the corresponding sides are in same proportion, then these two triangles have to be similar by definition, because angles are also equal and sides are also in same proportion, so they are similar. So it is enough if we have two triangles and we are able to show that their corresponding angles match, then that's enough to say that they are similar triangles, okay, because naturally the proportion part will be satisfied. So this is the proof of that AAA test, okay. So now let's see what is next. Okay, AA test for similarity of triangles. Now just in the previous slide we discussed AAA test, right? We are checking three angles. Now what we observe is, if two corresponding angles of a triangle are matching, corresponding angles match, then the other angle, that is the third angle, has to match, because we know that sum of the angles of a triangle is 180 degree, or else it is always 180 degree, okay. So if two angles are matching with the angles of the other corresponding angles of the other triangle, then the third angle has to naturally match, okay. So by just checking two angles also we can come up with similarity of triangles. Now we know that for a given correspondence of vertices, when two angles of a triangle congruent to two corresponding angles of the another triangle, then the remaining angle of first angle is congruent to the remaining angle of the second triangle, okay. This means when two angles of one triangle are congruent to two corresponding angles of another triangle, then this condition is sufficient for similarity of two triangles, okay. So just like AAA test, that is three angles we are testing, if we check just two, that's enough for us to tell about the third angle. Suppose we have two triangles, one is one angle of the triangle is 50 degree, other is 40 degree, and in the other triangle also one is 50 and another is 40, and they are matching, then the third angle should be 90 degree on both the triangles, okay, and it has to match, okay, because sum of the angles of a triangle is always same. Hence if we check just for two angles, if the corresponding angles match, then the third angle will match the third angle of the other triangle naturally, okay. So just by telling about two angles also we can come up with the similarity of triangles, because two angles will imply three angles are equal and three angles will imply that the triangles are similar, okay. Yes, the next test is SAS test. SAS test means two sides and one angle, okay. So two pair of sides we have to check for ratios, or should be in same proportion, and then one angle, that is one set of corresponding angles, should be equal. For a given correspondence of vertices of two triangles, if two pairs of corresponding sides are in the same proportion and the angles between them are congruent, then the two triangles are similar. For example, now if you see here, triangle KLM and triangle RST, okay. So first KL upon RS should be equal to LM upon ST. If you check, both gives the ratio 2/3, okay. And angle KLM is equal to angle RST. If we have two pair of sides are in same proportion and one pair of angles are congruent, then we can say that the triangles are similar, okay. So this is the second test, rather the yeah, we can say second, because AAA and AA test is one and the same, okay. Next, SSS, that means all three sides we have to check. All three sides should be corresponding sides should be in same proportion, then the two triangles are similar. Now for given correspondence of vertices of two triangles, now correspondence are decided by the vertices, we are the order of vertices in which we write the triangle. Now if you write PQR and XYZ, P is corresponding to X, Q is corresponding to Y, R is corresponding to Z in terms of angles, and PQ corresponds to XY in terms of sides, QR corresponds to YZ, and PR corresponds to XZ. That is what they mean by correspondence of vertices of two triangles, okay. Just seeing the vertices should be able to see, tell what are the corresponding sides and what are the corresponding angles, because order of writing the triangles are really important. just like you learned in congruency. Okay, when three sides of a triangle are in proportion to corresponding three sides of the another triangle, then the two triangles are similar. Okay, so for example, if you have two triangles PQR and XYZ, if PQ upon YZ is equal to QR upon XY is equal to PR upon XZ, then PQR are now, if here you observe, though the triangles are this, the similarity, the vertices have been of different order. Why? Because PQ upon YZ, PQ's corresponding side is YZ, and QR's corresponding side is XY, and PR's corresponding side is XZ. So triangle PQR is similar to, so for PQ it should be YZ, and for QR it should be XY, so ZYX. Okay, so when you write the similarity, we have to be very careful about the order of the vertices. Okay, because here P is corresponding to Z, Q is corresponding to Y, and R is corresponding to X. So according to the ratios and according to the angles, we have to carefully write the vertices, because this similarity, when we write, this means P is corresponding to Z, Q is corresponding to Y, and R is corresponding to X. Triangle's name you can write in any order of vertices, but when you write similarity, the order matters because correspondence comes with the order of the vertices. Okay, now properties of similar triangles. There are three important properties. Triangle ABC, any triangle is similar to itself. Okay, when two figures are similar, when they have same shape, obviously ABC has same shape as ABC itself. Okay, so any triangle is similar to itself. Next is, if a triangle is similar to second triangle, and second triangle is similar to the third one, oh sorry, not this is transitivity. Here we have symmetry. Symmetry, if one is similar to DEF, and then DEF is similar to ABC also, it is vice versa. Okay, if we say triangle ABC is similar to triangle DEF, then other way around also it is true, triangle DEF is similar to triangle ABC. Next is transitivity. In transitivity, triangle ABC is similar to triangle DEF, and triangle DEF is similar to GHI, then the first triangle is similar to the third triangle, that is ABC similar to GHI. Okay, this is called as transitivity. Okay, so these three properties are satisfied by similar triangles. Okay, yeah. So thank you for listening to me, guys, and if you like the video, please share it with your friends, and please subscribe the channel. And if you have any doubts regarding the lectures, then please write in the comment section. You can also follow us on Instagram and post your comments or post your doubts over there. Okay, at s_g_Friendtor. Okay guys, bye, see you soon.